In this question, we have the function f of x is equal to 5x squared minus 2x minus 1. We want to find the first derivative, the second derivative, and then determine where the function is increasing, decreasing, and then find if the function is concave downwards on a certain interval, and find the interval in which the function is concave upwards. So in this case, we're going to start by finding the first derivative. F prime of x is equal to 10x minus 2. And then f double prime of x is equal to 10 in this case. So the answer here is 10x minus 2. The answer here is 10. Now, in order to find where the function is increasing and decreasing, we want to find the critical values. The critical values can be found when we put f prime of x is equal to 0. So to find critical values, we make f prime of x is equal to 0. So we're going to do that. We have f prime of x is equal to 10x minus 2. We're going to make this equal to 0, and then we're going to solve for x. To solve for x in this case, we're going to add 2 to both sides of the equation. So we will have 10x is equal to 2, and then we divide both sides by 10. So we will have x is equal to 2/10 or 1/5. And that is the critical point that we have. Since we have one critical point, that means the domain of the function is going to be cut into only 2 intervals. Because we have 1/5 here, so we have an interval that is before 1/5, which is the interval from negative infinity to 1/5. And we have the interval after that, which is from 1/5 to positive infinity. We always work on open intervals here because we know that the first derivative f prime of x at x is equal to 1/5 is equal to 0. We know that the tangent line at that point is horizontal. So now that we have our intervals, we're going to test the sign of f prime of x on both of these intervals. So I'm going to build a sign diagram here for the first interval and the second interval. So I have the interval from negative infinity to 1/5, and I have the interval from 1/5 to positive infinity. Next, I will find testing points or values, and then I will find the sign of f prime of x, which is in our case 10x minus 2. So I'm going to choose the points. The first point that I can choose from negative infinity to 1/5 is 0. The point that I can choose from 1/5 to positive infinity is 1. Now I'm going to plug these values in the first derivative and figure out the sign of the first derivative. If I plug 0 in here, I will have 10 times 0 minus 2, that is 0 minus 2, which is negative 2. So the sign is negative in this case. And to figure out the second one, we're going to plug 1 into the first derivative. So I will have 10 times 1 is 10 minus 2 is 8. So the sign is positive in that case. After I found the sign of the first derivative on each of these intervals, I can say that the function is decreasing on the interval from negative infinity to 1/5, and it is increasing on the interval from 1/5 to positive infinity. So to answer the question, we say that the function is increasing on the interval from 1/5 to positive infinity, and the function is decreasing on the interval from negative infinity to 1/5. The last part of the question is asking about concavity. In order to figure out the concavity of the function, we need to figure out where the second derivative is negative or positive, and in order to do that, we need an inflection point. To remind you of what inflection point is, imagine that we have this graph right here. The inflection point is the point where the graph changes behavior from concave downwards to concave upwards in this case. So let's say this is the inflection point. This is the inflection point. At this point, the second derivative of the function is going to be equal 0. After we figure that out by making f double prime of x is equal to 0, we will have some intervals to test. Now, this part of the function, as you can see here, is concave downwards. In this case, if we do the testing, it's going to show us that f double prime of x is less than 0. And this part of the function is concave upwards. And if we do the testing only, we can figure out that f double prime of x is greater than 0. So after we find the intervals and test those intervals, if we figure out that f double prime of x is negative on this interval, then our conclusion will be the function is concave down. If we found that f double prime of x is positive on a specific interval, we're going to say that f is concave upwards, or concave up in this case. So let's do that. From the beginning, we figured out f double prime of x, and the answer was equal to 10. Now, in this case, we cannot find any inflection points, and the reason for that is because we cannot make f double prime of x equal to 0 in this case. It's not possible because it is equal to 10 in this case, and I don't have any variables here, so it's always going to be equal to 10. I can also assume that f double prime of x is going to be always greater than 0 because 10 is greater than 0. So because f double prime of x is always positive, I'm going to say that f of x is concave up all the time. On all x values. In other words, so f of x is concave upwards on all of the x values. In other words, it is concave up on the interval from negative infinity to positive infinity. To answer the question now, we know that the function is concave upwards on negative infinity to positive infinity, or in other words, on all of the values of x. And as a result, because f double prime of x is always positive, we say that the function is not concave downwards. So there is no interval where the function is going to be concave down. So we're going to say this does not exist in this case. So I hope this video helped you understand how to answer this question when you have a quadratic function. And I will see you in a different video.